Hey guys, can everyone hear me?
Yes.
Awesome. How is everyone doing this semester? Thumbs up. That's good. Make sure. Okay, that looks good. Awesome. Okay, so welcome everyone to Math 230. I'm Scott, so not Professor Conrad or etc. You can just call me Scott, or if you're uncomfortable with that, Mr. Conrad, I guess. So sorry for the rather disorganized start of the semester. So we had a really weird and unprecedented thing happen. Like we changed the course coordinator like 4 hours, or not 4 hours. We changed it yesterday, basically the day before classes started, which is kind of insane. And so the entire like structure of the course was kind of upended. So we had, a bunch of different things changed. The number of exams and the date and everything, the breakdown of the grades and everything. So there was some uncertainty about that until basically today. So I'll be sending out the course syllabus. In fact, I can go ahead and let me go ahead and upload that because I think he's finalized that, and we can talk about it a brief bit. Are you down? There we go. Okay. And then, so I'll put up like the section syllabus. So we're going to have a course syllabus, which is just like the overall thing, like when we're covering what in lecture, info about the textbook, exam dates, exam policies, that kind of thing, grade breakdown. And then I'll have a section syllabus, which has just like office hours, just whatever our section policies are regarding quizzes and that kind of thing. Which I am still tweaking a few things, but I'll probably have that to you definitely by the end of the week. But yeah, once again, really sorry for the how disorganized it's been. We'll rectify that ASAP. Okay. In fact, let me go ahead and upload this now. Let me add it in files. Okay, here's the link. Whatever. I'll do that in a sec. I will just open it up here, and then we can look at it and discuss it. Okay, let me do that. Okay. Alrighty. So I'll just go over this really quickly. If you have any questions, you can always email me. By the way, my preferred, I'll mention this in the section syllabus, but my preferred method by far of reaching me is through Canvas. I'm much more likely to see it quickly and respond to it in a timely manner if you email me through Canvas rather than through my psu.edu email. Just okay. So we're going to be using. I'm not a fan of this, but we're using an online learning platform called Achieve. And I'll send out the info on how to sign up for that. So that's where the homework is going to be done. And we'll have like two different kinds of homework, just sort of like warm up stuff called learning curves. And then, or at least we did last semester. I believe that's how we'll do it this semester also, but that remains to be seen. And then also we'll have like homework assignments, and those will be done on a chapter by chapter basis. So I'm going to try to assign the learning curves, and we'll talk more about those once we get everything hammered out. But I'll try to assign those probably around the day that we're going to be talking about the stuff. And then the homework for a given chapter will probably be due about a week after we finish talking about a given chapter. I believe that's how I want to do it. So unfortunately, so this is unusual, different than how we did in previous semesters, but unfortunately, the online text is going to be required, which it was last semester also, but it was free last semester. Probably, I'm guessing because of COVID, but now they're no longer offering it for free. So unfortunately, you're going to have to purchase the e-text and access to Achieve, because that's where all the homework is going to be done. Once again, I'm really not a fan of this, but so that will be, I believe, $105, which is nonsense, but that'll be for the ebook and also access to Achieve. And I'll send out info on how to do that. I used to just scan the textbook and send it out, and then we would do like hand in homework in person. And so you never had to pay these freaking sharks any money, but well, unfortunately that's not how it is this semester. Okay, so there are going to be 4 exams this semester, 3 midterms, and then a final. And these are all going to be administered through Canvas. So all of the midterms are going to be given on a specific day. Not 100% sure how we're going to do this now, but the way we did it last semester was we would have 3 different time slots for each for a given exam throughout the day. Oh, there we go. Right, so the time slots are 10 to 12, 6 to 8, and 6 p.m. to 8 p.m., and then 8 p.m. to 10 p.m. So the exams are going to be 1.5 hours long. The time slots are 2 hours, but you have 1.5 hours within there to do it once you start it. So if you want to have the full 1.5 hours, then you need to start, you know. So for example, if you want to take the 10 a.m. to 12 p.m. slot, if you want to have the full 1.5 hours, then you would have to start by 10:30, because no matter what, the exam closes at 12. And we'll talk more about that as we near the first exam. And then the final is actually going to be open for several days. Let me see. Oh, sorry, no. Sorry, I'm just looking at this for the first time now also, because we just got this. Final exam we schedule any day during the final exam. Ah, okay. Right. Okay, we'll talk more about this later because I'm not 100% clear what this is saying. But it looks like the final exam will be during, it'll be available for a few days. And I guess you schedule the day you do that. We'll return to that. My apologies. That looks different than what we did last semester. Okay, so grade breakdown. Okay, so we're going to have, so the exams are going to be worth, each midterm, the 3 midterms are going to be worth 100 points each. The finals going to be worth 150. And also, unlike last semester, this semester, we do, just like in previous semesters, so last semester was kind of different. We actually had 7 self-contained midterms rather than a cumulative final. This semester, we're going back to how we had it before. So we have 3 sort of self-contained midterms, and then a final, which covers new material since the previous midterm. And it'll be heavily focused on the newer material, but it's also cumulative. And so it's going to contain maybe like 40% of the final will be stuff from the first 3 midterms as well. So the final is going to be cumulative, but it's going to be more focused on the newer material since the 3rd midterm. So yeah, that's worth 150 points. Each of the midterms are worth 100 each. And then the remaining 150 points is going to be divided between, I'll figure out exactly how we do this, but the homework from Achieve and then quizzes. And since we're going back to the 3 midterms instead of doubling the number, I'll probably have weekly quizzes starting not this week, but next week. And those will likely be administered through Canvas, but I'll figure out exactly how we do that. And then the usual boilerplate at the end. But yes, any questions so far about any syllabus stuff? That's a no. Okie doke. Okay. Alrighty. Then I'm going to go ahead and start the first chapter. Cool. Is there anything else I wanted to mention? I think that's it. Okay. Oh, also, so I'll send out links for this also, but I'm going to record these lectures, and I mean, I would suggest you attend lecture always, but that's not always possible. And if you miss it, or if you'd like to go over what was said in lecture again, I'll be posting the recordings of these to the course YouTube, and I'll send out a link to that as well. Okay. All right. So come on, man. There we go. Let's talk a bit about vectors in the plane. Oh, it's doing it again already. You'll love to see it. I haven't, and I have not. Would that be helpful? So the way I've mostly been just using the whiteboard on Zoom, and it seems to be kind of weird the way it saves all of that. I'll see if I can find a reasonable way to do that, or maybe I just need to use another program. I'm not sure, but yeah, I'll see if I can find a reasonable way to do that. The problem is like there's like some erasing and then some other stuff, but I'll see if I can figure something out for that, if that would be helpful. Microsoft Teams works really well. I'll write that down and I'll look into that. Probably don't have time to give a tutorial on that right now, but yeah, I'll look into that. I'll look into that. Okie doke. Also, my handwriting is somewhat notoriously terrible. So if it becomes illegible or was never legible to begin with, please let me know if you're unsure what it is I'm writing, and I will try to clean it up. But don't let me start getting into completely legible chicken scratch. Please speak up if you can't tell what I'm writing. Okay. Yeah, another program would be nice too, because it randomly does this thing where like you'll see it multiple times, but like ever since Zoom updated last semester, I'll be writing and then suddenly it'll be drawing lines all over the screen, and it drives me absolutely insane. So yeah, something else would be nice, something more organized as well. Okay, all right, so let's look at vectors, in particular vectors in, in the plane. See, there it is. Yep. Don't know why it does that. Okay. So class goes until 12:05, right? I believe. All right. Okay. So, so as you probably know, we usually represent the plane. As we have the x-axis and the y-axis, and it's a set of ordered pairs, basically. And the first coordinate of the ordered pair gives you how far along the x-axis you go. Let me do it like this. Let's say this is, nope. So let's say that is A along the x-axis, and that is B along the y-axis, and that gives us the point AB. And the set of all such ordered pairs is the plane. And so the first coordinate is a real number. Second coordinate is a real number. And so we usually call the plane R cross R for the reals cross the reals, or more commonly, just r squared or r2. And I'm sure you're all very familiar with that from the past, well, basically everything. Okay, and so this semester, we're going to be using vectors throughout the entire class. So a vector is a mathematical object with, so it only has, it has two pieces, right? It has two characteristics of a vector. So it has direction. It's any object which has both direction and magnitude. And in fact, as we'll see, it only has direction and magnitude. It doesn't have something like location or something like that, as we'll see. So magnitude can mean different things, but we'll look at a couple examples and then discuss what they mean there. So for example, velocity is a vector. So velocity is commonly incorrectly used as interchangeable with speed, but velocity, it includes the speed of something, but it also includes a direction of travel. So the direction of travel is sort of built in. And the speed the object is moving is the magnitude of that velocity vector. So if an object has velocity, it has a direction and a speed, and the speed is a magnitude in that case. So force is another common vector. Love it, love it. So force has a direction of the force's application and also the magnitude of the force. And then even something as simple as an arrow, which is one very common way we represent a vector. So just a directed arrow, like say this guy here. So it obviously has a direction. It's the direction of the arrow itself. And if you have an arrow, the magnitude of that vector is the length of the arrow. And in fact, we're very commonly going to represent vectors as arrows. So for instance, if you have 2 points in the plane, say the point P and the point Q, then we can look at the vector which starts at P and ends at the point Q. So we can look at the arrow, which the tail is at P and the tip is at Q. So if you have 2 points in the plane, P and Q, and you look at the vector which starts at P and ends at Q, sorry, that's supposed to be a tip there. we usually write it like this, right? PQ, and you put an arrow over it. And in fact, that's how we're usually going to represent vectors when we write them as letters or that sort of thing, as we'll see. We usually put an arrow over them. So that's the vector. Which has a tail, or the starting point, at the point P. And the tip, or the ending point, at the point Q. And of course, as we discussed before, it's just an arrow. It has direction, the direction it's pointing, and it has magnitude, which is the length of the arrow. It's a vector. Okay, so if we're not specifying points, we usually use letters to represent vectors. And in the book, they use boldface letters. Obviously, when you're just writing stuff down, it's difficult to use boldface. So we do the same thing here. We put an arrow over it to specify that it's a vector. So we usually write it as just a letter. So we refer to it as a vector V, but we put an arrow over it to specify that it's a vector. So we call it by letter names, but we put a vector, an arrow over it to specify that it's a vector. Let me say arrow to signify. Thank you. That we're talking about a vector. Okay. So we say two vectors are parallel if you take those vectors and you look at the lines, you sort of continue them in both directions, and you look at the lines containing the vectors. So two vectors are parallel if the lines containing the vectors are parallel. My goodness. I need to get another stylus. My apologies. So for instance, if this is our vector V, and down here, say this is our vector W. If we look at the lines containing those, I'll try to. The lines containing those guys are parallel. So those two vectors are parallel. So if you look at the direction, they're pointing in the same direction. But similarly, if I look at a vector which points in the exact opposite direction, say this vector here, U, that's also parallel to V and also to W. They're pointing in opposite directions, but they're still parallel. So those three vectors are all parallel. Whereas this guy here, not parallel to those because the lines containing those vectors are not parallel in that case. But a good thing to remember, if vectors point in the same direction or if they point in the exact opposite direction, they're parallel. Okay, so we say two vectors are equivalent, or we'll just use equal also. But we consider two vectors to be the same thing if they agree on the two properties of a vector. They have the same direction and they have the same magnitude or length. And we'll use magnitude and length interchangeably because when we're talking about arrows, they mean the same thing. But right. So if you think about them as vectors, so if here's one vector here, let's call it V, and then we have another vector over here, W. So the fact that these are in different points, in different places in the plane, doesn't matter. All that matters is that they have the same direction. These are pointing in roughly the same direction, pretend they have the exact same direction, and the same length. In other words, if you can translate one of these guys onto the other and you get the exact same thing, then the two are equivalent. So in other words, vectors don't have a location. Location doesn't matter for vectors. Right, so we mentioned before that velocity is a vector. So suppose a train in Minneapolis has a velocity of northeast at 50 miles per hour, right? If another train in Miami has a velocity of northeast at 50 miles per hour, the two trains have the same velocity. It doesn't matter that one's in Minneapolis and one is in Miami, right? The location doesn't matter. The velocities are the same for the trains, right? Northeast, 50 miles per hour. They have the same magnitude, the speed in this case. They have the same direction. So that's true of all vectors. Vectors only have magnitude and velocity, or sorry, magnitude and direction. They don't have location, right? So you can move a vector around in the plane and it stays the same vector. And two vectors are equal if they have the same direction and the same length or magnitude. Okay, any questions about anything so far? Okay, got 10 minutes. Okay, so We won't use this terminology too much, but if we have the vector PQ, vector which starts at the point P, ends at the point Q, so we say the vector PQ let me just write it like this, is based at P. Right, the vector starts at the point P. So since we said it doesn't matter where you are in the plane for a vector, you can move it around and it's still the same thing. It stands to reason that it doesn't matter where this vector starts. If we wanted, we could just start the same vector at the origin. So in fact, it's convenient to think of, often, to think of a vector as starting at the origin. So every vector is equivalent to a single vector based at the origin. Right, so you can, this is obvious, right? You just take your vector and you translate it so that it starts at the origin. And we'll call the origin O. Right, we call this point P, this point Q. We'll just call the origin O. Makes it simple to talk about. Right, so if we move this guy PQ, ooh, that's not even close. Whatever, let's pretend that's the same direction. Right, we've moved it. It becomes a vector which starts at the origin, points in the same direction, has the same length. Let's say it ends at the point P prime. So we have the vector OP prime, starts at the origin, ends at the point P prime. Let me say it this way. So we'll be using this term a lot. So we'll just call it vector which starts at the origin, ends at some point P, is called the position vector. For the point P. Let me just, okay, forget about this guy up here. That's okay. So we just have some vector which starts at the origin and say it ends at the point P. So there's sort of a relationship between this vector and the point P that it ends at. It's a special relation we'll use a bunch, and we sort of think of them as sort of similar. They're related in a way, and we'll use them often semi-interchangeably. But we say that the vector which starts at the origin, ends at some point P, is the position vector for that point P, for the endpoint. That's if it starts at the origin. So we use that term quite a bit. Okay. So, so this leads us to another way of representing vectors. So we can represent vectors geometrically as an arrow in the plane, or as we'll see next time, in space in R3. Or we can represent them sort of algebraically. Using the following notation. Suppose P is a point AB. In the plane. Come on, don't do this to me. And we look at the vector which starts at the origin and ends at that point P. In other words, if we look at the position vector for this point. We'll call that guy. No, we'll call that OP. That's fine. So P is a point AB. Then the vector which starts at the origin and ends at that point P, we call it the vector AB. Whoops. So to differentiate it from, because a vector and a point are two different things, we use the sort of the round parentheses for the point as usual, but we use triangular brackets for the vector AB. And we do this to distinguish it from the point, right? A point and a vector are two different things, right? A point is just an ordered pair in the plane, doesn't have a direction, doesn't have a magnitude. A vector has both of those things. It's a different object, so you need to use a different notation to distinguish the two. And we'll kind of use points and vectors sort of interchangeably, but you need to make sure to differentiate the two when you're describing them. So the vector which starts at the origin and ends at the point AB, the position vector for the point AB, is the vector AB. Does that make sense? Any confusion on that point? So we're starting the vector at the origin in this case. As we'll see in a sec. It doesn't have to start at the origin, but yeah. So that vector is the vector AB. So this is sort of the algebraic representation of a vector, or we say it's, we write it in component form. So this first guy here, this first component is the x component. The A is the x component, right? So how far in the x direction this vector extends. I could also go in the negative direction. And the second guy is the y component. So how far in the y direction this vector, this arrow extends. Could also go in the negative direction. So that's the component representation of this vector OP here. Okay, so let me just mention. So for vector V, in component form, if we write that out, if it's a vector AB, So then the magnitude of V, we write the magnitude of a vector as, so you write the vector, and then you use sort of double absolute value signs to represent the magnitude. So we said that if it's an arrow form, the magnitude of a vector is just the length, right? And so it shouldn't matter how you write this vector down. If you're talking about the same vector, obviously the magnitude has to be the same, right? So if we have the vector AB, remember that's the vector which starts at the origin, ends at the point AB, then the magnitude has to be the length of that arrow, right? And you can just use the distance formula. You have the vector AB. The length of that is A minus 0, it starts at the origin, squared, plus B minus 0, starts at the origin, squared, square root of all that. So if you have the vector AB, the magnitude is the square root of the sum of the components squared. Thank you. So the magnitude of the vector AB is the square root of A squared plus B squared. You take each of the components, you square them, you add them up, and you take the square root. Right, and that corresponds to the length of the vector which starts at the origin and ends at the point AB, right? We look at the difference in x, that's A minus 0. The difference in y, B minus 0. You square those guys, A squared plus B squared, and you take the square root of them. That's the distance formula, in other words. And then also I want to mention very quickly, suppose we have a vector which starts at the point P and ends at the point Q. So if P is, let's say, A1, B1, and Q is the point A2, B2, often we want to write this in component form so we can do algebra and stuff with it. So remember, so the way we defined the components was we took our vector and we moved it so that it starts at the origin. And then we look at the endpoint, right? If the endpoint then is AB, then our vector we call AB. So what we want to do to this guy is it starts at the point A1, B1, ends at the point A2, B2. We don't want it to start at the point P, A1, B1. We want it to start at the origin. So what we do is we take this thing, we move it rigidly by A1 in the X direction and B1 in the Y direction, or so minus A1 in the X direction, minus B1 in the Y direction. Then the first point, P, is now the origin. The second point is going to be the endpoint, and that's how we define what it is. So it now starts at the origin, right? So we've subtracted A1 from the X coordinate, and then B1 from the Y coordinate. So now the endpoint is the X component is, so is A2, but now we've moved minus A1 in the X direction. So it's A2 minus A1. And then we've moved by B1 and minus B1 in the Y direction. So the Y component is B2 minus B1. So we've just taken this guy, we've rigidly moved it. And now the endpoint is Whoops, sorry. A2 minus A1, B2 minus B1. And we'll do an example of this tomorrow. You'll get lots of, you'll do this over and over and you'll get used to this. But any questions about anything today? Okay, all right. Well, then that is it for today. We will finish up talking about this chapter tomorrow, and then we'll probably start a bit of the next chapter. I will send out the syllabi and stuff, as much info as I have. And then also later today, I'll send out info on how to sign up for Achieve. Get the e-text and the online platform for homework and everything. Yeah, I'll see you guys tomorrow, and have a good day. All right, bye.
I had a question.
Sure.
For now, I'm like enrolled in the wait list.